Okay, this is Eli Zadik's extra credit chem video. I dedicate this to Steven and Mr. Fitch. And here we go. So we have 58.2 grams of pentane, which is C5 H12, and then is burned in 38.9 grams of oxygen. Is burned in 38.9 grams of oxygen. And oxygen, as we know, is the symbol O2. Right? Okay, so then 13 grams of CO2 were collected. Great. So there we have it. So our first step we're gonna have to balance the chemical equation. So we have C5 originally, right? So we have C5, okay, plus H12. C5H12, sorry. What am I saying? C5H12 plus O2 is burned with CO2 plus H2O. Okay, so we first have to figure out how many carbons, hydrogens, and oxygens we have, and then we're going to balance the chemical equation. So we know we have first carbon, we have 5 carbons here, so that's 5. And here we have 1 carbon. Hydrogens here we have 12. Hydrogens we have 2. And then oxygens here we have O2, so that's 2 oxygens. And here we have 1 oxygen. 3 oxygens, I'm sorry, the O2 plus 3 oxygens. Okay, so what we first have to do is we're going to balance the C's. Okay, so we know that here we have 5 and here we have 1, so we have to multiply this by 5. So we're going to multiply 5 here, and we get 5 times C, which is 5 now. But then we also have to multiply it times the oxygens, which gives us 10 oxygens. 11 oxygens plus the 1 here. So we have 5 and 5, which is balanced, and now we have 2 hydrogens and 12 hydrogens on this side. So what we have to do is we have to multiply this times 6, and that gives us 12 hydrogens. Then we also get 6 extra oxygens. So we have now 10 oxygens here, plus 6 oxygens here, which gives us 22 oxygens. No, we have 10 oxygens here and 6 oxygens here, which gives us 16 oxygens. 16 oxygens. Okay. Now, we have balanced these equations. So we have 5 and 5, 12 and 12 here, but then we still have to balance this oxygen to get it, times multiply this times 8. So we're going to do times the coefficient of 8, which gives us 16. So we balanced the chemical equation now. So we have C5H12 plus 8O2 plus 5 is burned with 5CO2 plus 6H2O. Good, everyone understand. Great. So B, we have combustion. This is the chemical reaction. Okay. Now we're going to go on to which is the limiting. Sorry, my cameraman. Okay, which is the limiting reagent? Which is the limiting reagent? Yay, chemistry. Okay. Okay, we have the question mark, so we have 58.2 grams of C5H12. Okay, and then we have 38.9 grams of O2. Try to make sure that was aimed at carbon dioxide. Okay, now we have, we're gonna do the parentheses, we're gonna have to do the conversion factors here if any of you can see. So we have 58.2 grams of C5H12. Where do we get that? From the problem. Okay, and over 1. And then right here on the bottom, we're gonna have to put grams of C5H12 so this can cancel out. So first put the C5H12. Mr. Fitch, you told me to work on that, so I'm putting the numbers first. You're welcome. And then above, we have 1 mole of C5H12. Okay, and here we have 12. 12.
Where do we get that number?
Where do we get that number? From the periodic table of elements. Yes. Okay, then we're gonna multiply that times 5 moles of O2 over moles of C5H12, so that can cancel out. Moles of C5H12.
Where do we get that?
Where do we get that? Mira asks. The answer is the balanced chemical equation, Mira. This is why I was placed in chemistry advanced and she was in chemistry. Over 1 mole. Okay? And we're gonna have to squeeze this one in. On the bottom, we have 44 grams. Move my head, okay? 44 grams of CO2 over 1 mole of CO2. You didn't see that one coming, did you? CO2.
Where did you get that number?
Mira asked, where did I get that number? I have no idea, Mira, so stop asking questions. Okay, there we are.
Periodic table.
I got it from the periodic table. Mira, you're right. That was good. She's got me there. Okay, so then the second one, we're gonna have to do the second equation, okay? So now we have on top 38.9 grams of O2. Everyone, this is insane. Over 1, okay?
Is he actually trying this out?
Over 1 mole of O2. Mr. Fish, you follow me? Okay. Over 32 grams of O2. Okay, so we're gonna cancel these out. Please move the camera, thank you. These cancel out. And we just put a 1 here because we have nothing else to do. So we fill that in. And then the next one here, we do 5 moles of CO2. Yes. Over 8 moles of O2. Mira asks again, after I told her to stop, where did we get that? We get it from the balanced chemical equation up here. O2, everyone. You follow? Okay, so then these cancel out, right? And these cancel out, right?
They don't cancel out.
They don't cancel out. What are you saying, Mira? You multiply these, and these cancel out. These right here.
Nothing cancels out.
Nothing cancels. What the hell do you mean it doesn't? It does cancel out.
Okay, wait. Should I pause? No, 38 multiplies by 5 and multiplies by 4 and divides by 12.
Yes, but O2 and O2 cancel out. What do you mean? That's the purpose of putting it there.
Just keep going.
I'm sorry for my stupid associates. Now we have 44 grams of CO2 over 1 mole of O2.
Your hand is in the way.
Oh yeah, sorry. Thank you. 1 mole of CO2. Okay, great. So here, we now know that this is a limiting...
No.
Mira, not a comment, not another word, not another word. Okay, so we have the theoretical yield. Yay. It's very right. Which is 33.43 grams of CO2. Can you guys see
How
that?
did you get this number?
Well, we multiplied it out, Mira, and then we divided it by the bottom.
Yeah.
Yeah, thank you.
And how can you tell which one is the limiting reactant?
This is the one that runs out the quickest.
Yeah, great.
Thank you. So 13 over 33.43. We're not done yet, Daniel. Almost 39%.
And that is the
No,
what?
0.39%.
39 point.
14 divided by 0.